I'm Bridget Meintz. I'm a postdoc at Oregon State University, and I'm managing a grant that we received from USDA OREI in 2017 on developing multi-use naked barley for organic farming systems. So we are working with 5 states. Oregon is the leading institution, and then we have collaborators in Washington, Minnesota, Wisconsin, and New York. In the grant, we wrote in research, extension, and education components, and we're working to evaluate agronomic, food, feed, malting, and brewing performance under organic conditions. And in addition, we'll be measuring economic, environmental, and health benefits of organic naked barley production and products. So you might ask yourself, what is naked barley? Because given the what is covered barley? Yeah, good question. Look at that. So most of the people at this conference seem to be interested in vegetables. And let me tell you, you should also be interested in grains because they make a great rotation. So anyways, this here on your left is covered barley. And so there's a single gene that controls the covered versus naked trait. And I'll say we use those terms rather than hulled versus hulless because we think they're a little bit more clear and it makes it a little bit more interesting. Talking about naked barley, you can make all sorts of jokes. One of those shortbreads is made with buck barley. We also have streaker that you ate at dinner last night. Anyways, we like to keep it fun in Barley World. So, anyways, the reason that we're focusing on naked barley is currently there are 3 primary end uses of barley: food, feed, and malt. Exactly, malt for beer and whiskey. That's an important end use. But the market is sort of stratified based on whether the barley has a hull or not. So typically hulled barley is used for brewing because that hull protects the little germinating plant during the malting process, and it also provides a natural filtration system during brewing. It also is often used in animal feed, but if you want to eat that seed, it needs to be pearled first because the hull is not very appetizing. So you've probably had pearled barley. That hasn't likely been bred for nutrition or flavor. And it is also no longer whole grain because the pearling process is a physical abrasion process. It removes the hull as well as some of the bran and germ. So naked barley does still have a hull, but it threshes freely like wheat. And so that can be eaten directly. It can work as an animal feed, and we're working on figuring out how to malt and brew with it. So in addition, the hull accounts for about 10 to 13% of the weight of the grain. It's made primarily of cellulose and lignin, and it actually has a dilution effect on the other components. So this graph is really tiny, or this chart's really tiny, but basically you see increases in percent protein, starch, beta-glucan, which is a soluble dietary fiber that makes barley really good for you. We also see increase in test weight, and we see decrease in overall total fiber with naked barleys as well as cellulose, and we do tend to see thinner kernels because the grains are just naturally smaller, but just with the removal of that hull, you tend to get an increase in protein and starch and beta-glucan because that does not exist in the hull. And so that can be beneficial, especially in the feed market. So I'm just going to sort of go over what we're doing for our project. We don't have a lot of results yet because we just started. We only have 1 year of field trials. But the field component, as I mentioned, we're in 5 different states. So we put together what we're calling our regional trials. So that's 20 advanced breeding lines or newly released varieties. We're growing those in the fall and the spring. So we have both fall planted barley that's planted in usually October and harvested in July. Spring planted barley is typically planted around March to April and harvested in late July or August. And so both of those can work into different rotation systems. So with these trials, I should say we also have what we're calling our diversity panel. So that's a panel of about 400 naked lines that we've collected from breeding programs around the country and around the world, as well as we've gotten some lines out of GRIN. And both of those trials have different purposes, but on both of them we're assessing for agronomic traits. Weed competitivity is something that hasn't really been looked at too much in barley, and so we're trying to figure out how to measure that. Resistance to biotic and abiotic stresses are a typical part of our breeding program, but there are certain diseases, especially the smuts, both loose and covered, that we're really focusing on looking at for organic systems because they can be quite problematic. We're also interested in quality traits, so with this project, we're actually, with the naked barley, we're trying to breed for lines that will work as a food, feed, or malt. And so we need to look at the quality for all of those. And then with the diversity panel, we're actually going to be doing some genome-wide association studies. So that panel was just genotyped by the USDA now that the government is back open. And so we're really excited to look at some traits that are exclusive to naked barley, including threshability. So not something we have to worry about in hulled barley, but for naked barley, might not be super easy to see, but both of these are naked barleys, and there is a difference in whether that kernel threshes freely from the hull. So this top one still has a lot of hulls on it. That's not going to be accepted in certain markets. The U.S. does not have standards because naked barley is not a commodity crop, and in fact there's quite little of it grown, but trying to increase that. But Canada has been growing naked barley for quite a while, especially for the swine market. So they do have some standards for food and feed grade, and I have just been spending quite a lot of time visually scoring all of the lines in our trials, and this is maybe a bit difficult to understand, but this on the left is the regional trial, and I have 5 locations. Those are the different colors with the varieties or breeding lines on the bottom, and you can see that there's both a genotype effect as well as an environment effect as well as interactions. So the highest line are going to be the ones that thresh really well, and the lowest are the ones that thresh poorly. And so we have one here at the very end that threshed wonderfully at all locations, and then everything else is sort of in the middle. So that's going to be interesting to look at further. Also, just really briefly, I have a histogram from the diversity panel, and so you can see we have quite a range of threshability in that. So once we start doing the GWAS, we'll hopefully be able to pick out the genes or QTLs that control threshability. Another key thing for naked barley is resistance to embryo damage. So on a wheat kernel, the embryo is a little bit more embedded in the kernel, but on the barley it tends to be pretty exposed. And so depending on how you set your combine, it can actually break all the embryos off the grain, which may not be a problem for food or feed unless you're trying to sprout it, but for malting, which is a germination process, you need those embryos, as well as if you're growing for seed. So you can see we have a range from embryos being completely removed, some embryo damage, and then embryos intact. And so we're looking at trying to measure those using germination testing and visual scoring, as well as I'm trying to sort of implement a system to actually thresh these really hard and see which ones still maintain their embryos. Yield is another issue. So due to the fact that the kernels, the naked kernels, are 10 to 13% less weight, we tend to see lower yields for the naked barleys. However, there's been very little breeding done in the US, so we think that we can improve this, and we have seen in our breeding trials that some of the naked lines can compete with the hulled lines. So that's one of the things that we're working on. Moving into the quality traits, so naked barley has been shown to be a superior feed for non-ruminants because they don't need that additional cellulose from the hull. And so the swine industry, especially in Canada, has really moved into using naked barley as a feed. It can also be good for poultry. However, the beta-glucan that I mentioned that's great for human health can be a problem because it increases viscosity in the gut, and so it leads to a phenomenon known as sticky droppings in poultry, which is, as you can imagine, not desirable. So we're working with Dr. Jim Hermes at OSU. He's the poultry extension specialist, and we're about a month into a layer study with him to see how that might work. Another potential way to get around the beta-glucan issue, so in conventional systems you can use an exogenous beta-glucanase to break it down, not allowed in organic systems, so sprouting, which will activate some of those enzymes, may be another way to get around that. Malt barley, so barley is the optimum substrate for malting, brewing, and distilling. However, most malt barley has been bred with a hull. As I mentioned, there are some benefits to that. However, one of the main benefits to using naked barley for malting and brewing is what's called malt extract. So that's essentially the potential alcohol that you can get out of that kernel. And because the hull doesn't contribute to alcohol yield, when you remove it, overall you get a higher malt extract. And so that's really appealing to brewers, but there's a lot of work to be done, especially in this system. So we have a small-scale malt house at OSU that we're using to do pilot malts, and then we'll be doing some brewing trials. So there is quite a bit of research actually on malting naked barley, so I'm working to try and dial in a protocol, but there hasn't actually been much done on brewing trials. And so we will be working with OSU Fermentation Science Program to use different technologies to brew with the naked malts that we produce in our malt house. And we have worked already with several breweries to give them some naked malt, and they seem to be into it. So that's just anecdotal, but with the increasingly competitive craft brewing industry, I think people are looking to set themselves apart. So naked barley could be a way to do that. And there may be interesting new flavors that come out of that. Food barley, we're really lucky to have Dr. Andrew Ross, who made the shortbreads that you got to eat today at OSU. He's a cereal chemist. He also has a bakery in the basement of the crop science building. And so we certainly benefit from that because he does a lot of product development work with the shortbreads, for example. And then we have a new graduate student working with him on this project to do functionality testing. So as I mentioned, naked barley, not a commodity crop. People don't really know how to cook with it, bake with it. And so we'll be looking at all of the lines in our trials to sort of establish a baseline and then be able to give out information on how they'll work in a bakery setting. We do a bit of sensory exploration. That's Lane Selman's word because it's not official sensory science, but we find as breeders that we can get a lot of valuable information from events like last night. Even though we didn't do ballots, I got a lot of good verbal feedback from people on what they liked, what they didn't like, etc. And so that's really fun. And we do some more sort of formal sensory exploration with ballots and more trained panels. So then we do a lot of outreach opportunities. So this is one of them, but we like to really talk to people about what we're doing because education is going to be key. This is my almost last slide. But we also have an education component where we work with K-12 schools to bring barley into the classroom as a substrate for teaching about math, science, agriculture, and nutrition. So if you're interested in that, we do have a few lesson plans that we've come up with. And then with that, I would like to acknowledge the Barley World crew and all the collaborators on the grant. If you are interested, we have 2 websites, actually an eOrganic website as well as barleyworld.org. We have Instagram and Facebook, and then I will be giving several webinars for eOrganic. I already gave one, but if you have anything you'd like to learn, let me know, or there's my email for other questions. So, yeah, thanks.
We can take a couple of questions.
Hi, thank you for that. I couldn't train my eyes fast enough on that threshability slide. So as a grower and a researcher, I'd love to know what maybe your top 3, 4 cultivars were.
Yeah, so on this one, the top one was actually Purple Valley, which is an heirloom. So that's sort of interesting. I've been finding that the naked barleys that have been grown in cultures where they continue to consume barley regularly, they tend to have better threshability and better resistance to embryo damage, which is no surprise. And so, a lot of these other lines have hold parentage at some point, and so working with some of those heirlooms to perhaps introgress the threshability in is definitely something I'm interested in. And then some of these other ones are just breeding lines that did pretty well.
This is just for my edification, maybe you know the history. I'm just curious as to why naked barley was taken off as a commodity, and what the history is. There any kind of quick history of that?
Naked barley was never a commodity crop, as far as I can tell. So the mutation dates back about 8,500 years. So it's certainly an old crop, and it maintains, has a rich cultural significance in areas like Tibet, Ethiopia, the Andean region, where barley remains a staple crop. However, in Europe, barley became known as the poor man's food. So brown bread was made with barley, white bread was made with wheat. Barley has lower levels of gluten than wheat does, and so you can't make a loaf with 100% barley flour. And so they were really flat and dense and not quite as appetizing. But fun fact, gladiators were known as hordearii, or barley men, because they subsisted on a diet of barley and it made them really strong. Yeah. So yeah, we're bringing it back.
You're already with good commercials going on.
Okay, thank you.
Thank you.